we have discussed about the importance of automated machine learning that enables you to automate the processes of feature engineering, feature selection, hyperparameter tuning, and model training. So let's take a look now at the walkthrough associated with the exercise in this section. You have used the automated ML section of the Azure Machine Learning Studio to initiate a new automated machine learning run that was called flight delay. And the first step when you have started the configuration of the automated machine learning process was to register a new data set called Flight Delays AutoML. And while registering the dataset, you have specified the URL to be used for that particular dataset. And Azure Machine Learning used the URL to download the dataset and also to create the entry in the dataset registry. The other important thing that you have done while configuring the dataset was to eliminate some of the columns from the dataset like path, month, year, time zone, year_R, and time zone R. So as you can see here, the resulting data set does not contain those columns. They have been removed as instructed by you while registering the data set as part of the automated machine learning experiment. So the next thing that you did while configuring the automated machine learning experiment was to specify that the target column for the prediction is the ARR del 15 column, and then you also specified this to be a classification task. And finally, you have selected the metric, which was the area under the curve weighted, and you also specified the threshold for that metric as being 0.7, the threshold where the exploration process finishes. So once that experiment was run, automated machine learning has basically started to explore various options of hyperparameters and machine learning algorithms as part of the process. And as you can see here, automated machine learning ended up with the best option among all the options that were tested, which was a model based on the light GBM algorithm. And the scaling process that was used was maximum absolute scalar. Also, you can see here as a result of your automated machine learning run that the metric value for the area under the curve weighted metric that you have specified as the primary metric for your automated machine learning run reached a value of 0.73, which meant actually that you have exceeded the threshold that was set as the minimum bar for the experiment, and hence at this point the experiment has finished. The other things that you can see here is the list of models that were produced by automated machine learning. Just a quick note here, in the interest of keeping the runtime of the automated ML experiment to a minimum, we have intentionally specified a threshold of 0.7, which was actually met by the very first a combination of algorithm and hyperparameter that were tested by automated machine learning. You can try on your own, for example, setting a higher level for the threshold, and then you will see automated machine learning trying a larger number of these algorithms. So if you take a look at the resulting machine learning model, you can check the visualization sections. And the visualization section will provide some of the charts associated with the performance of the resulting model, like precision versus recall, the ROC curve, and also the lift curve associated with the model. And again, you can also see the confusion matrix that results for this particular model that helps you understand some of the metrics that are associated or that can be derived from the values presented in this matrix.